Well, welcome back. This is our final night of trigonometry. Tonight we're going to focus on several identities, but our main one's going to be called the Pythagorean identity. So let's talk about some trig identities that we should already know. Now these identities will pop up through the rest of the video. Most of them should sound familiar, and they will pop up in our Pythagorean identities as well. So let's start with sine theta. Basically, what I want to do is just be able to rewrite sine theta, and to do that I would basically say sine theta is really just sine theta over 1, right? Anytime you wanted to say a number, you just simply put it over 1. 5 is really 5 over 1 as a fraction. 10 is really 10 over 1. So sine theta is just sine theta over 1. Cos theta then is also cos theta over 1. Tan theta, well, you've probably guessed it, is tan theta over 1. Now here's where it gets tricky. We've talked about another way to represent tangent. Tangent is also sine theta over cos theta. We've talked about that in previous videos. Now, these are our three main trig identities here. Once we have those down, the reciprocals are very easy to get. Remember, cosecant is the reciprocal of sine. So in your head, you're saying, well, sine is simple. Sine is sine over 1. Therefore, cosecant is its reciprocal, which means take that fraction and flip it. 1 over sine. Secant is the reciprocal of cosine. And if cosine is a fraction is cos over 1, then secant, if you flip that, is 1 over cosine theta. Cotangent, again, can be rewritten two ways because it's the reciprocal of tan theta, which is tan theta over 1. So 1 over tan theta. Or, because tangent is also sine over cosine, cotangent is then cosine over sine. Okay, so these are the trig identities that we need to be pretty good at in order to move on. Again, flashcards are a great tool if you don't have these memorized yet. So here's what I need you to do. In a fairly big picture here, we're going to sketch our x and y axes, and then we're going to create the unit circle. Now, I want to remind you what's important about the unit circle. We said unit represents the number 1. So that means every point here is basically 1 away from the origin. So let's say we're going to pick a random point P. So go ahead and do the same thing. We're going to call this point P, and we're going to say obviously that's x comma y. And now we're going to draw our triangle from the origin out to point P. So I'm going to start at the origin, and I'm going to go over a certain amount, and then I'm going to go up a certain amount until I hit point P, and then I'm going to connect to make that triangle. Remember, it should look like a member of the bow tie we drew a while back. So this is my right angle, always on the x-axis, and theta is always at the origin. Okay, now again, since unit circle meant 1, the distance from the origin out to the circle always has a length of 1, and we know that because of that word unit. Now I'm just going to assign some variables here. If I went over this distance, again that's my x value, and if I went up this distance, that is my y value. So according to the Pythagorean Theorem, which is a squared plus b squared equals c squared, a and b are sides, and c, remember, has to be the hypotenuse. So if I use the triangle we just drew and plug that into the Pythagorean theorem, my a could be my x distance, so that's going to become x squared, plus my b would be my y distance, so that's y squared, equals my hypotenuse squared. So that becomes x squared plus y squared equals 1. All right, now you might be thinking, okay, well, x squared plus y squared is the equation of a circle that has a radius of 1, and that's what that unit circle is. I'm not shifted left or right or up or down. I'm centered at the origin, so that's x squared plus y squared, and I'm 1 away. Now here's where the Pythagorean identity comes in. Remember, this was called the Pythagorean Theorem. The Pythagorean identity puts trigonometry into it. Okay? In trigonometry, let's go back to this unit circle. We said instead of calling it x comma y, in trig, just like alphabetically x comes before y, we call it cosine theta, sine theta. So watch. Now, instead of saying x squared plus y squared equals 1, I am saying cosine theta squared plus sine theta squared equals 1. Now that wasn't magic, guys. Where did I get that from? Well, x is the same as the cosine, and y is the same as sine. Now, here's how it's going to get written in trigonometry notation. It's going to say cosine squared theta plus sine squared theta equals 1. Notice where the squared is. It's on the trig function, not on theta. Okay, so cosine squared plus sine squared equals 1. And really, all that means is x squared plus y squared equals 1. So I need you to box this in. This is our Pythagorean identity. Okay, the Pythagorean theorem, you can put a THM here for theorem, is right here, but the Pythagorean identity is cosine squared plus sine squared equals 1. Now, think about this. When I add 2 plus 4 is equal to 6, is that the same thing as saying 4 plus 2 equals 6? Absolutely, you're still adding 2 and 4. So you could rewrite this and say, instead of saying cosine squared plus sine squared equals 1, obviously that's the same thing as sine squared plus cosine squared equals 1, right? We just reverse the order. So either way you want to memorize it, go for it. But again, it's just cosine squared plus sine squared equals 1. An identity is true for all values. So we spent a lot of time talking about identities in the beginning of the year. But again, today our focus is on the Pythagorean identity. So now you have to be able to derive 2 other Pythagorean identities. So here's the deal. You want to always memorize the first Pythagorean identity. There's actually 3 of them. So the first one says it's cosine squared theta plus sine squared theta equals 1. Now you want to derive, and that word just means to get, manipulate. Go get these other 2 identities. So here's how you do it. In your notes, let's star this. You're first going to divide all terms by cosine squared. And if you write it out, it's really not that hard. You don't have to memorize it, just write it out. So I'm going to take the main Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And the rule says divide all the terms by cosine squared theta. So put each term divided by cosine squared theta. Okay, and this is how you're going to show it on the test next week. Now you just evaluate this. What is anybody divided by itself? 5 divided by 5, 10 divided by 10, cosine squared divided by cosine squared. Anybody divided by itself is 1. Plus, okay, sine over cos. Which trig function is popping in your head? When I see sine over cos, I immediately think, look back at your notes if you need to, if you don't have it memorized. We just talked about these reciprocals. Tangent. And because this is squared and this is squared, I'm just going to call it tangent squared theta. Okay, 1 over cos. Ignore the squared for a moment. 1 over cos. Okay, because I see the cos in there, I'm thinking which trig function? Secant, cosecant, or cotangent. And again, look back at your notes if you don't have it memorized. I'm going to say that is secant. And because this bears squared, we're going to square this one. Let's go ahead and box that in. That is the second trig identity. Okay, and all we did is we divided each term by cosine squared. Again, don't memorize this if you don't want to, if you don't have to. Just remember you're dividing by cosine squared. Now to get the third one, I'm going to do the same thing. So let's make a note. We're going to divide, and instead of saying by cosine squared, I'm going to divide by sine squared. So I'm going to start with my main function, which is cosine squared theta plus sine squared theta equals 1. And instead of dividing by cosine, we're now going to divide by sine squared. Okay, this is going to get me my third identity. So I'm going to start with the easy one. Anybody divided by itself, we said, is just the number 1. Okay, I'm going to go over here, and I'm going to say, okay, 1 over sine came from cosecant, and because that's squared, I'm going to call it cosecant squared. And lastly, well, I know sine over cos is tangent, therefore cos over sine is cotangent. And because these are squared, this is going to get squared. So cotangent squared theta, and box that in. That is the third Pythagorean trig identity. And there's only 3. Okay. Example 1 here. Find sine x given cos x equals 3/5 from negative pi over 2 to 0. Now we're going to solve this 3 ways. We actually solved these equations maybe a week or 2 ago, and we solved by sketching. And we're also going to solve with the Pythagorean Theorem. So let's first do the one we're familiar with. Let's solve by sketching. So I'm telling myself I know cosine, so I'm saying that's adjacent over hypotenuse. And now here they're telling me exactly what quadrant to draw it in. I have to be between negative pi over 2 and 0. Well, I'm going to go ahead and label this. Remember that's 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. Also known as 0, 90, 180, 270, 360. Well, this is saying go negative pi over 2. Well, positive pi over 2 is 90, so I'm going negative 90 to 0. So that leaves me in the 4th quadrant. I'm going to draw my triangle. Remember, the right angle has to sit on the x-axis, and theta is always at the origin. Now I'm just going to appropriately label my sides. We said adjacent over hypotenuse. So adjacent means next to, hypotenuse is here. I'm going to use my Pythagorean theorem to figure out that missing side. Those 3 squared plus x squared equals 5 squared. Maybe you're familiar, that's called a Pythagorean Triple. I get 9 plus x squared equals 25. X squared equals 16, therefore x equals 4. Now here's the catch, guys. Notice this direction is going down. So not only is it 4, but it's a negative 4. And there's where we have to be real careful. Again, just common sense. For me to get to this point, I go positive 3, but then I go negative 4. Okay, so now it says find sine. So now I'm just going to look at my picture once I have them labeled and figure out sine. When I say sine, I'm thinking so katoa, O over H. So I'm going to say the sine of theta is equal to, there's my opposite, negative 4 over the hypotenuse. And we did this, like I said, 2 weeks ago. Most people were really darn good at it. But now you have another tool in your toolbox. You have to solve using Pythagorean identities. So here's what you do. You start with the Pythagorean trig identity. Cosine squared theta plus sine squared theta equals 1. And you plug in what you know. Cosine of x is 3 over 5. So I can replace this cosine theta with 3 over 5. Now here's the one catch. The formula is cosine squared. So you have to wrap that bear up and square it. Why? Because there's a squared here. So you know cosine of x is 3/5, but you have to square it. And then I'm going to leave plus sine squared theta equals 1. Now we just have to clean up our math. When you square a fraction, you square the top and you square the bottom, so no, you don't need a calculator. 3 squared is 9, 5 squared is 25, plus sine squared theta equals 1. Obviously, I want to solve for sine squared theta, so I'm going to subtract 9 over 25 from both sides. So again, you shouldn't need a calculator. I'm saying sine squared theta equals. Remember, when I subtract, I just want common denominators. Another way to say 1 is any number divided by itself. Well, if the denominator is 25, I'm going to call it 25 over 25 minus 9 over 25. Do you see what I did there? 1 is equivalent to 25 over 25. Now I can subtract the numerators and keep the denominators. So sine squared theta equals 16 over 25. Now remember, I just wanted sine, so to get rid of the square, I simply take the square root. And remember, that gets me a plus or minus. So sine theta will either be positive, radical 16 over 25, or negative, which is plus or minus. The square root of 16 is 4. Square root of 25 is 5. So it's either plus or minus 4. Well, I still have to use the idea about which quadrant I'm sitting in. And they're telling me again I'm in quadrant 4. So if I think all students tip cows, cosine is positive, but sine is negative. So I know I'm going to need a negative 4 out of 5. So notice 2 ways to do the same thing. I don't know what's easier for you. Maybe you prefer one over the other. Maybe this is easy because we've done it that way a bunch of times. But maybe you prefer a little more algebra. Either way, we're going to practice with both methods. Okay, find tan x given cos x is negative 5 over 13. So let's first solve by sketching. Okay, so I know I'm the quadrant from pi over 2 to pi. So 0, pi over 2, pi, 3 pi over 2, 2 pi. So I didn't have to guess. They came out and told me, this is the quadrant you're sitting in. So right off the bat, all students tip cows. Only sine is positive. Everybody else will be negative. So keep that in mind for your answer. If you're finding tan, make a note already. You know you want a negative answer because only sine is positive in that quadrant. So I'm going to go ahead and draw in my right triangle. Hypotenuse has to sit on the x-axis. Cosine is adjacent over hypotenuse. So just common sense, guys, if you start at the origin and you go to the left, would that be a negative or a positive number? Definitely negative. So I'm going to assign that negative to the 5 on the adjacent, and the hypotenuse is always positive. A quick Pythagorean theorem to get the missing side. Again, this is a triple if you know it. That's great. If you don't, use Pythagorean theorem, and I get a 12. Now it just says, what's the value of tangent? Now keep in mind, we already know we want our answer to be negative because of the quadrant we're sitting in, and let's see if it works out that way. I'm going to say that's opposite over adjacent, so katoa. So I'm going to go with a 12 over negative 5. Okay, now I'm going to solve with trig identities. So let's start with the main rule. Sine squared plus cosine squared equals 1. Or cosine squared plus sine squared. Remember, that order doesn't matter. I'm going to plug in the cosine value. So I'm going to say that's, sine squared plus negative 5 over 13 squared equals 1. So I'm going to get sine squared plus 5 squared is 25, 13 squared is 169, equals 1. Remember, my goal is to solve for sine squared. So sine squared theta equals, now I want a common denominator. So if this denominator is 169, that's simple. I'm just going to make it 169 over 169 minus 25 over 169. So that leaves me with 144 over 169. To get rid of that squared, we're going to take the square root. Don't forget the plus minus. So I get plus or minus, what is that, 12 over 13. Now, again, just based off the quadrant I'm sitting in, which is quadrant 2, I know my sine value should be positive. So I know that sine theta is equal to positive 12 over 13. Now, the only catch here is they wanted tangent. So now I can say, based off my reciprocal identities, tangent is equal to the sine value over the cosine value. So I can say that's 12 over 13 divided by, if I look back, cosine was negative 5 over 13. And now I'll just say, okay, the common denominator is 13. It's a complex fraction. I'll multiply that top and bottom by 13. So on top I get a 12, and on the bottom I get negative 5. So again, either way you do it, we should get the same answer. It is known that cotangent of A is less than 0, and sine A is radical 7/3. Determine the value of cosine A in simplest radical form. So here they're really implying that you should not be touching a calculator. You have to have a radical in your answer. So I'm first going to start by figuring out what quadrant it tells me, because it doesn't come out and say, quadrant 1, quadrant 2, quadrant 3. You kind of have to figure it out on your own. So remember, all students tip cows. I'm going to start with the easy one. Sine is clearly a positive number. So we're all positive, sine is positive, tangent's positive, so that's out, and cosine is positive. So now I've narrowed it down, and they tell me that cotangent's negative. Well, remember here, everybody's positive, so now I know that that quadrant's eliminated, and I know I've got to be in quadrant 2. So I'm going to go straight to the identities instead of drawing this out. Cosine squared plus sine squared equals 1. So cosine squared theta plus, substitute in, radical 7/3 squared equals 1. So cosine squared theta equals, when I square a radical, that just eliminates it, and 3 squared is 9. Whoops, that was a plus, sorry, equals 1. So again, no calculator needed. I'm going to call this 1 really 9/9, and I'm going to subtract over 7/9. So I get cosine squared theta equals 2/9. Again, to solve for cosine and get rid of that squared, I'm going to take the square root, but don't forget you get a plus minus. So cosine theta equals, I don't know the square root of 2, so I'm going to leave that as the radical 2, but I do know the square root of 9 is the number 3. So I get plus or minus radical 2 over 3. Now, remember, you're finding cosine, and we just said we're in the second quadrant. So the only term that's positive here is sine, and it's reciprocal. Therefore, I know cosine has to be negative. So I would say my final answer is negative radical 2 over 3. Given that cosine theta equals 0.198, and look, they tell you the quadrant, how nice, find sine theta. So again, all students tip cows, and label my angles, my quads. This is 0, pi over 2, pi, 3 pi over 2, 2 pi. And they're telling me I have to be between the 3 pi over 2 and the 2 pi. That's this quadrant here. Now again, why is that important? Well, cosine is positive, which I can verify with a positive number there, but everybody else is negative. So I'm implying right off the bat that my sine value better have a negative answer. So again, I'm going to go with Pythagorean identities. And a big trick is, like, when I see a decimal, I automatically go Pythagorean identity, because there's no really triangle to draw out. So cosine squared plus sine squared equals 1. And it does say nearest thousand, so I'm probably going to need a calculator. So this is 0.198 squared plus sine squared equals 1. Like I said, I'm going to jump to my calculator. I'm going to type in 0.198 and square it. I get 0.039204 plus sine squared equals 1. I'm going to subtract that number over, so 1 minus 0.039204. Let's see, so sine squared equals 0.960796. 0.960796, and verify that on your calculator. And then again, to get rid of this square, I'm going to square root both sides. So I get sine theta equals plus or minus 0.98020202, repeating. So now if I scroll back here, it's set to the nearest thousandth. So real quick trick, guys, if you think of the number 1,000, how many zeros does it have? 1, 0, 0, 0, 3. So that means I need 3 decimal places for thousandth. So I'm going to say point negative, because of the quadrant I'm sitting in, 980. And that should do it. Alright, so let's first start by sketching. Let's get a nice sketch drawn. So all students tip cows. They tell me tangent is positive, so that means this quadrant's out and this quadrant's out. And then somebody's negative, so that eliminates the first quadrant. Get my triangle drawn at the origin, right angle sitting on the x-axis. Now I see secant, and I have to think the reciprocal of cosine. So according to SOHCAHTOA, cosine is adjacent over hypotenuse. Therefore, secant is hypotenuse over adjacent. Hypotenuse is always positive, and so that's going to make this side, the adjacent, -3, and that should make sense, guys. If you're at the origin and walk to the left, that definitely should be a negative number. Now, some people jump the gun here and want to slap a 5 on that side, and that's 100% incorrect. It's only a 5 if the hypotenuse is the larger side, and the hypotenuse is 4, so that can't be a 5. So a quick Pythagorean theorem, plus x squared equals 4 squared, will tell me that that side is actually, let's see, so that's going to get me x squared equals 7, x equals plus or minus radical 7. Now clearly it's not both positive and negative. We need to be smart. If you're standing, you walked -3 this direction and you go down, is that number going to be positive or negative? I would definitely say that's a negative number. I'm going to call that side negative radical 7. Now I can answer the question. The question actually says find the value of tangent. So according to SOHCAHTOA, tangent is opposite over adjacent. Negative radical 7 over -3, which of course is just radical 7 over 3. And notice tangent should come out positive because tangent owns that quadrant. Okay, now we're going to solve it using the Pythagorean identities. So I want you to start with that main identity. Cosine squared plus sine squared equals 1. Now notice, you don't actually have sine or cosine to plug in. Now you could get cosine because you have secant. So if you know secant, you could just flip it to get cosine. But remember, there's two other Pythagorean identities. Look back at your notes. We divided everybody by cosine squared, and we divided by everybody by sine squared. Is there one of those identities that uses a tangent and a secant? Well, I think if I go through and I divide everybody by cosine squared, go ahead and do the same thing. It's good practice. Let's see what we get. Cosine over cosine is 1. Sine over cos is tangent squared, because those are squared. And 1 over cosine squared is secant squared. Now I can use the other Pythagorean identity to solve this. So I have 1 plus tangent squared theta equals secant squared. So I have to take negative 4/3 and square it. So that's 1 plus tangent squared theta equals, it's going to be a positive 16/9. So I'm going to say tangent squared theta equals 16/9 minus 1, which is really 9 over 9. So tangent squared theta equals 7 over 9. To get rid of that square, take the square root of both sides. Don't forget the plus minus. So I get tangent theta equals plus or minus, that's the square root of 7 over the square root of 9 is the number 3. And then again, I just have to determine if I want a positive or negative. Well, based off the quadrant, so you're always making this, in quadrant 3 where tangent's positive, I would say that's a positive radical 7 over 3. And there you have it. Well, I gotta tell you, great job tonight with those trig identities. Flashcards are going to be your best friend if you don't have those memorized. We look forward to some great practice in class tomorrow.